So let's start with some questions. You guys got some questions for me? Things you want to know? Anything? There's no questions, then we're just gonna go do other stuff. Oh, 1 second, I'm just gonna paste in the group. Right, re-ask your question, Mister. Alright, you can't pop values that are in the middle of a stack because that's why it is called a stack. You can't just randomly access any value on it. You can only access the top value. That's the reason why there exists a stack. So theoretically, you could probably do it, but it's not like you shouldn't do it. So yeah, I hope that answers your question. How to access the value of scanf. So you mean you store your value, like you ask scanf to put some value somewhere, and you want to access what the user inputs, right? Like, you just want the user input. Is that what you mean? All right, so let's see. Let's do a little scanf thingy. So we're just gonna edit this code and this scanf instead of printf. So it's gonna be scanf and an RDI. It's going to be the output. So the output is going to be RDI, and this is going to be format D. And we have to put something else. You want to see my face? You really want to see my ugly face? All right, so let me just get my stuff set up. Hey, it's the boss. Welcome. Want to face cam on this shit? I don't know. All right, I'm gonna put a face cam on this shit because you asked for it. You get it. All right. All right. You ready? You ready for it? You ready for the face cam? Here we go. There you go. There's your face cam. Cool. Happy? Thank you. So let's explain Scanf, right? Um, we're going to manually. All right, so let's go to the manual and Scanf. So this is the printf section. It's in this manual, which you can find over on Brightspace. And here we have the format. So Scanf takes a thing, a format, and it takes an input. LD stands for a long digit, so you can also input very large numbers. And the number is actually a pointer to, or a reference to the input of the user. Or no, it's a reference to a memory address where the scanf is going to put the input of the user. Does that make sense? So this is basically where the input is going to be stored. You have to use this variable later on to print that program. So this is just C code, and this is the first argument, as we remember, that is RDI, I believe. Yeah, RDI is the first argument, and RSI is the second argument. So you have to put this in RDI and reference to wherever we want to store the input in RSI. So this is the format string, which is a string, or ASCII is %LD, and we're just gonna copy this over into our thing. So first off, we want to subq 8 from RSP. So subq $8 from RSP, and we know that just pushes the stack pointer down over here. So that's cool. And after that, we want to leaq, all right? Leaq. This is basically loading the effective address. Cool. So instead of this move q, well, the first argument is actually the format, so we'll have to put that up there. So it makes sense, it's in chronological order. So the format is in the first argument, and the second argument is going to be, this is yeah, it's going to be a digit format. Yeah, let's just make our commenting a little bit precise. I made a mess in my code, but I'll explain it again in a later bit. All right, so we're missing something. Oh, yeah. So I missed a little thing that you have to do before you do a call to printf, and that's basically clearing the racks. You don't want any stuff in your rack, so don't use a vector args. And basically this is stack stuff, so you don't want any stack stuff. I usually do that just before the print or the call, because it makes more sense. I'm using XOR, which is just way faster than whatever else you can think of. Very optimized. I'm using Sublime Text. You can just Google that.
Malvin. Malvin. Kali kong parobit.
So why is there no sound? Right. Now there should be music, right? Indeed. You can't pause online games. So yeah, so as we saw over here, we have to not use factor arguments, and that basically means that we're not going to put any extra variables on the stack. We're not going to put our extra variables on here for printf, scanf, whatever. And so it's only going to use the arguments in the registers, as we know from yesterday. This is the order in which we put the first argument, the second argument, the third, fourth, fifth, sixth, and after that you have to put your stuff in the stack. And again, below here is all the explanatory stuff, so it's not really from the program. Anyway, first off, we sub 8 from RSP, so we move the stack pointer down, and we put the format in there as the first argument, and we put some value, whatever value in RSI. Okay, so let's just put the base pointer to the actual start of our program now, and let's put the stack pointer over here, so we can see we just sub that thing over there. So it's now pointing here, and this is where it's going to store the stuff. So we just want to put the RSP into the RSI. So this is actually going to RSP, and in RSP is the address of the line it's at. Sorry. And that's over here. And instead of taking the value with a move, it would move the value. It will now load the address, so it goes a step back again and takes that. And now takes that address, I believe, because usually you do something like that, and it's basically the same thing. It moves down over here, but instead of taking the value over there, it's taking the address. So you load the effective address into RSI. So that's also, you can also read that back in the manual over here. They use -8% RBP and a format string, and they use the slow method. And now that's basically all the. So you load the address of the stack variable. So these are called stack variables. So we create a stack variable, which is just a temporary variable on stack, as the name suggests. And this should load over here, and it should load this address, a reference to this place in memory, and put that into Scanf. And so then Scanf runs, it asks the user for an input, and the input will be stored on the stack over there. And as you know, with stack variables, we can just push or pop the stack variable off the stack again. So it should be under RSP when we do that stuff. We can just push it into RDI this time. And then we're just gonna print it again. So we're just gonna grab this printf thing and have fun over here. Now we're just gonna print the actual input thing from stack. All right, and it's gonna format it as a digit. And it's actually up. Nice. Yeah, so formatting this as a digit this time. So otherwise it's gonna print it as a string, and we don't want that stuff. Second argument is going to be the input thing from the stack. I'm not gonna use any variables from the stack, so this should work, right? So this actually has to be RSI, because that's the second argument. So let's move this R6, delete that. Excuse me, why you do that? Oh, I see what's going on. Sorry, I'm making a mess here. But this is actually the second arguments, so we'll actually wanna put that over there. Makes sense. So we first put the first argument in, we pop the second argument off the stack because Scanf loaded it over there. And this is a little bit confusing, but whatever. I'll explain it if you don't understand. Then we print f, and then we do our ending. That should work. So GCC our auto. Yeah, we have to cd to assembly documents assembly dank tutorials, and now we should be able to GCC compile our stuff and GCC input. So first it's going to put my name because I didn't change that, and we're gonna put a beautiful number, so 2, and there is your output, 42. And this is obviously very ugly and stuff, so a different way to print this is actually using another print and making it more fancy, but I'll leave that to you to make this stuff more fancy. I'll change this real quick too. So input a number blocks, and instead of a /n we'll just do space, so it spaces it out, and you can input your number there. So let's just recompile it and redo it, and you can put a number, and 69 is printed. And that's how Scanf works. And yeah, that's the basics done for Scanf. So the Think Smooth, you need to use subq and liaq for the reason that first, if you were here at the stream yesterday, you know that the stack pointer is actually pointing to the base of the program at the start of the program because of all this stuff I explained yesterday, simplified into one instruction. The stack pointer is now pointing somewhere, and subq basically points the stack pointer, or it actually moves the stack pointer 8 down. As you can see, this is 48, this is 40, it moves it down. or up the stack really, and this has some value you don't know, and it's just pointing there right now. That's where the input's gonna be, and format D is basically just the digit format, so our scanf is going to scan it as a digit. So if this contains, if I say like 30, 40 or something, it will recognize that as a digit and format that as a digit and not as 2 characters. Otherwise, it would copy this and say, all right, this is the ASCII character for 4. So let's go to the ASCII table real quick, and so just the ASCII table, and so it's gonna look up 4. All right, where's 4? Oh, it's 4. It's over here. So that's in hexadecimal 34. So it's going to say 34, and the 2 is 32. So 34, 32. Let's see what that's gonna be. So it's gonna say, for example, something like 34 and 42, I don't know, something like that, and it will save it like that instead of the actual value 42, which is in hexadecimal to decimal. I don't know what is that, or whatever. Just put 42. I don't care enough. I'm not in the mood to think. And so now it's pointing at our input. So we input number 42 and it's stored as a number 42. So that's what that does. Like subq, it puts the RSP there, and LeaQ basically means load effective address. It means that we take RBP, that is this is RBP, then we take the address of that, so whatever is there, and it's going to subtract 8 of that address, so it's basically going to be the stack pointer. I mean, you can try it out with the stack pointer. Let's see if that works. Oh, what? Oh, wait. I think I have to do that. And yeah, it works. It works. Just trust me. It works. See? So this actually makes more sense. But this doesn't make sense if you, for example, subq 16 for 2 variables. If you want to have 2 variables, but then you can also just do that, and that should also work fine. Except we have to pop another value, so probably gonna get an error anyway, because we're doing some malicious stuff. Because actually, this is the value above, and then we're popping the value under that. So this is not really what we want to do. We probably want to do that. And now it works, as you can see, 32. But now we didn't clean up our stack, so that's problematic. So we have to use another pop, or just move the base pointer back. So if that makes sense, if there's no questions about that, what subq does, so that moves the RSP pointer. If you want to have 1 variable, you just subtract 8. If you want to have 2 variables on the stack, subtract 16. If you want to have like 200 variables on the stack, you just subtract 1600. You know that. And LeaQ is just loading the effective address of RSP. So I believe this should also work. Like, let's just try it. You know, let's have fun. Let's have fun. It works. So I don't know why they are using move Q while this just simply works. Like, I'm just following the book, and this works fine. Like, why is there a stack pointer? Why doesn't it just always point at the top of the stack? Well, that's why there is a stack pointer, because the stack pointer is pointing to the top of the stack. There is no value here. Like 69 is just some garbage from another time we played with memory. If we just move the pointer here, we can overwrite this with whatever value. I mean, the stack pointer is always pointing to the top of the stack no matter what, because if we are allocating something here, we're just putting our beautiful number 69 in here. That's beautiful and all, but if we call a function, they might use stack variables and just override that stuff, like bam, like destroyed. But if you have your stack pointer over here, this value is basically safe for you, so nobody's gonna tamper with it unless they want to tamper with it, and then they're doing malicious stuff. But values within your stack frame, they are safe, they are yours. You claim those spots. Whatever is outside of that stack frame between RBP and RSB, you don't know what's gonna happen. You might just explode your PC, like just kaboom, like some dank Andy is gonna come over and ruffle stomp all the values you put in there. So that's why there is a stack pointer that always points to the top of the stack, and it defines your frame. And that's why you don't want to play with your stack pointer, you just want to keep control over it, so you don't have problems. XOR is quicker because it's one of the most basic operations the computer can do. You can just put the register and the register through the XOR in the ALU, and boom, output, and it's done. It's slower than the move queue because move queue has to look up the value 0 from the constants table or whatever. It has to generate the number 0 from somewhere. Then it has to move that value from wherever that is into RAX, and that costs a lot more time. Yeah, so if you want to clear all of someone's data, you just move the RSP to the RBP. Well, not quite. The system does check that you are not going outside of your memory before you move your RSP. So if you move your RSP outside of your stack frame and like it's going to destroy your computer, it keeps it off and it's like, hey, don't do that. But you can destroy all your own local variables. Like you have your you have like a lot of values over here, and then you come here to whatever it is, F00 whatever, and here is your RSP now, and you have like a bunch of values over here, like la la la. Alright, cool. There's a bunch of values here. I don't know. What you do is just you move your RSP over here, and basically you destroyed all these variables. They're dead. Well, you could actually just move the RSP back. The computer might have done something to these variables, so the behavior is unknown, it's unstable, and you might crash your computer at some times. So just keep your RSP over here, and you can use all these variables, and they will be stable, and nothing will happen to them, and you'll be safe. Factor arguments, again, those are your stack arguments. So we are, for example, putting our stack pointer here. This can be a vector argument. This can be a vector argument. Basically means that you have an unlimited amount of, or like a dynamic amount of arguments, because you can only pass 6 integer values to a call function or to a function like that. And with stack arguments, you can just put way more variables in there. So you can just put like 1,000,000 in there, theoretically. And we'll just push 1,000,000 variables onto the stack. And what printf does is actually looks in your stack frame. It actually looks in your stack frame. Shh, don't tell them. But it's just gonna look, hey, you specified you had 8 vector arguments. Okay, cool. So this one, that one, that one, and that one, you know, and it just looks for 8. And it's going beyond your stack frame. It's gonna do some malicious stuff. It's gonna be some unpredictable stuff. So that's why you put it to 0, so it knows, okay, you don't have any variables there. Is that clear? I'm just gonna put our stack pointer back to where we're gonna have fun. And as you can see, I just used the move queue because RSP is already pointing to the place in memory I want it to be. So why use Lia Q? I don't know. Don't ask me. I just use this, but you can also just use Lia Q If you have something like this, for example, you have to use LeaQ because there's no way to say, okay, we're then going to take the register and subtract 8 in one go. You can't really say something like that, you know, this won't work. You'd have to subtract 8 from RBP, and in the meanwhile, it changes RBP, and you have to reset RBP back and do all kinds of dumb stuff like, why would you do that? Are you stupid or something? And that's why you have to use LeaQ to take the address of the value, and it corresponds to the AND operator in C or C#, so it's just a reference. So we have a number, a number variable, which is 7, and we take the address of it, we take the place in memory. That's why you use LeaQ, but I prefer to use RSP and move because we're now actually pointing to RSP, and it makes sense to use that. Again, if we use 16 or whatever more variables, then we probably do it differently, but it works. So this is the basics of scanf, printf, and it works. It's beautiful, and it's dank, you know, and it just works. And you can use more printfs and more scanfs to clean up this program a little bit. You can mess around with stack variables. That's your like extra homework for today, is just mess with stack variables, try out placing more variables in the stack, and like getting 2 inputs. It's gonna be useful to know that kind of stuff, and maybe play around with more constants and whatever. Just play around a little bit and get the hang of it. Just become a pro at it by experimenting. It's really important. So if there's any more questions or things you don't understand or whatever, ask them now. Where did you get sub-Q OX18 RSP allocate 24 bytes of stack on the stack? Where did you get that line of code from? Oh, from the cheat sheet. The cheat sheet? OX18 doesn't mean 24 bytes, but it's hexadecimal. So the 1 stands for 16, and the 8 stands for 8. So 16 plus 8 is, you can do the maths. Hint, hint, it's not 25. If a number is prepended with OX, the number is in hexadecimal. If it's appended with a 0, I believe it's octal. I'm not sure if that's true for assembly, but usually. So $OX18 is basically the hexadecimal 18, and that's not 18, that's 20. So yeah, I just spoiled your calculation. Sorry. And I can do an example with vector arguments, yeah. What I don't get though is how it doesn't do weird stuff. Yeah, so let's just print a lot of stuff. It's actually not my name anymore. So let's just input. And the first argument is going to be, I don't care. Let's see if this works. REI, RSI, RDX, RCX. All right, let's see if this works. Thing. Thing. into, I don't care, I don't know of any good names. So let's see if this is doing expected behavior or whatever, or if I'm doing something wrong. Nah, it doesn't work. Let's see if we can use vector arguments. So move 1 into RAX, and we actually use one vector argument, so use one vector argument. Okay, cool. And then this has to be pushed on the stack, so we're just gonna push beautiful value on the stack, like let's push and on the stack. Cool. And hopefully this works. Segfold. Cool. Yay. Maybe we have to pop it again. And let's just pop it in RX. I don't care. Just gonna override it in anyway. Segfold. Maybe this has to be moved in our RCX first. I don't know. Maybe I'm not gonna do an example with, what is it, RCX, RDX. Maybe I'm not gonna do a vector arguments thing. Nah, too difficult. I don't care enough. I don't care enough. Let's just do. So like that. Input. Too lazy for life. Okay, deal with it. Anyway, more questions. My music playlist. Non-copyrighted Twitch playlist. You just YouTube it, and I was there. Garbage. Cool. Where did I find the list of register address? Where did you find the list of register address? You and the English have very good friends, you know? You mean this, right? This list of register addresses. Where I found that. Where is that thing? I just go to cheat sheet and I look for calling a function, and over yonder we have the order. Okay, cool. We have the first argument, second argument, third, fourth, fifth, sixth. That's where you find it. I don't know if that stuff is also in the manual. Calling convention. Or the subroutine should always have proper stack frames. You should use the official calling conventions. Yep. So yeah, that's cool. So you can just read this thing through. It has a lot of information you can use. So also there should be, like, everything you need should actually just be in here, but it's never a wrong thing to Google things like this. And it's nice to have, you know, see what everything does. Also, someone wanted to know how to use multiplication. If you use imulk, it will multiply s, the source, sign full multiplication of RAX by s, so it will multiply RAX by s. The result will be stored in RDX and RAX, I believe. Like, the most significant bits will be stored in RDX, and the least significant bits will be stored in RAX. So that's why you have imulk there. And imul is just simple multiplication of source by destination, and this makes I think this won't store if the number becomes too big. You have a problem and start. So then it will multiply s by d and store the result in d, I believe. Yeah, multiply destination by source. Yeah, so use imul. So any more questions? No. Right, so any suggestions? You want to learn anything cool or whatever? I don't know. No? All speechless today. Cool. Then today we have a beautiful thing we're gonna do. And that's just, if everything is clear, nobody has any assembly questions anymore. So are we alright? Are we alright? Yeah. That's it? Alright, just I think this is a little bit overkill, so so let's do something else real quick. Just take a break from assembly and do something more interesting, right? Yeah. Okay, why is this thing doing weird stuff? Cool. Let's go into ANDYCRAFT and Andy. I mean, take a break from assembly. So in this game, you basically have to survive Andy, and there's a lot of Andy, so make sure your Andiness is completely Andy, and it's basically just Andy, you know. So it's a very descriptive game. You know exactly what to do because Andy. Yeah, let's just craft an Andy real quick so we can Andy. Some Andy. So the goal today, we're just gonna try and get Andy. If we get Andy, we can go Andy, right? So I'm like really professional at this. I play this game like every day. Like I'm a professional Andy player right now. And so I craft an Andy. And you can see it has Andy, Andy, Andy. Nice. So hopefully you don't find an Andy, because those are dangerous. Okay, cool. Oh. So, yeah, just relax a little bit. So, if you have questions again, I can go back into assembly, teach you some new things, but Now everything is clear, so we can just play some Andy. So, oh, nice. Yeah. And we need some more Andy. So we can craft a lot of Andy. Oh, we've got an Andy. Look, it's Andy. That looks fucked up. Yay. Alright, so cool. We've got some Andy here. You can download the Reese's pack. I'll probably upload it someday. I don't know. I'm too bored. So it's really difficult to find Andy in this game because there is so much Andy. So, yeah. We have a difficult time surviving here. Oh, Andy. Oh, we can craft more Andy. Nice. Yell in chat if you see Andy, because I need some Andy to craft an Andy, you know, so we can progress in the game. And we have to set up an Andy farm so we can grow some Andy, you know. Like, it's pretty illegal to grow Andy in real life, but this is a game anyway, so growing Andy is perfectly fine. Jeez, how do I find Andy in this? Like, okay. This is gonna be rough. This is gonna be rough. Like, this is all Andy, but I need to find Andy. Maybe the stack pointer is pointing at Andy right now. Oh wait, Java. What a joke. Doesn't have stack pointers. Java doesn't even have referencing and pointers. Too bad. But no Andy here, so I'll look a little bit further. Maybe there's Andy over here. Some Andy ore. Come on. Blocks, maybe. Oh. Look really, really closely to find Andy's ore. Might be really, really difficult. Because everything is Andy. Oh. Yeah. Well, this sucks. I guess I could craft some coal using Andy. Where's Andy? There's Andy. I need some Andy for my Andy. So we got some Andy, so we can burn the Andys to get some Andy. Oh my god, this game. Oh, Andy! I'm gonna kill Andy. Oh, Andy's on fire. Andy. That's pretty nice. I got some Andy. Now we got some Andy. So now we can actually explore this cave using Andy. Oh, so pretty. Yeah. So there is no Andy in this Andy. Like, how am I supposed to freaking survive without Andy? It's impossible. Yeah. You'd expect some Andy ore by now. Like, it's really difficult to see if there's any Andy ore here. Yeah. This might not have been the best idea to make everything Andy, but now even finding the littlest bit of Andy is gonna be impossible. Somebody keeping count of how many times I said Andy? Just shut up, Andy. Okay, I'm lost. This game is rough. It's very rough. I can't see shit in this cave. We got Andy. We got Andy, guys. We got Andy. I found Andy. Yes. Oh my dude. We found Andy. Now we can finally make progress in this game. Right, so nobody cares about assembly. It's all about Andy, right? Yeah, fuck assembly. Let's play ANDYCRAFT. It's the real game for real gamers. Like this is how you play games. Like this is how you get that YouTube money, even though you're streaming on Twitch. This is like the pro gaming stuff. Like look at this. Can't complain about graphics. They're like 256 by 256. You know, like ultra graphics, hardcore HD. Of course, Andy makes it very dank. Yeah. Getting bored already. Ah, just kidding. It's Andy. Alright. So, this is some Andy ore, I believe. This is Andy ore. Yes, it's Andy ore. Finally, gee. It's so difficult to see which is which because everything is quite Andy. This is Andy ore. Like the little speckles on the sides gives it away. I mean, it's still Andy, but a little bit less Andy. Yeah, I know, Andy. Just look at here. Here, it's Andy. It's pretty nice. It's pretty nice. Can't complain about that. And I'm lost already in this damn cave. I have to inspect every single Andy block to see if it's different from all the other Andys, like this one. And we know it's actual Andy ore. Wasn't the only piece of Andy ore here? Gee. Alright. Let's place down our Andy. And let's burn our Andy because I don't have any more wood. I'm kind of screwed. We can create one Andy. We need to find Andy ore. Some black Andy ore, you know. Oh, dang it. Well, we got one Andy. We can craft exactly nothing with Andy. Oh, dang it, Andy. No, 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 no. He's dead, Andy. Dang it. Can we kill Andy? Alright, I'm gonna kill Andy. No, 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 no. Where's... Oh, there is a dead Andy. Okay, cool. Oh, she. Oh, she. Andy's trying to kill me. What did I do wrong, Andy? I didn't go to your lectures. I'm sorry. I'm sorry, Andy. Ooh, good. We got some golden Andy. That's pretty nifty. Yeah. So, if you see any Andy coal, please tell me. I'm desperate. Oh, oh she, oh she, oh she. That CPU combat. Oh no, dang it! Almost dead. Andy almost killed me, and we have to get food like now before Andy kills us. Yeah, that's where I came from. Hopefully we don't die. Don't want to die in this world of Andy. I mean, it's gonna be scary. Never gonna find a way out. I'm so professional. I'm pro, elite, MLG player. Alright, that's probably where we came in from. Yeah? Well, it does lead to the exit. Except we're almost out of Andy durability, so let's be careful. Let's use some Andy. Yeah, let's just Andy out from here. Andy is chasing me, oh no. Yeah, I'm just gonna bet Andy is gonna kill me once I get up here. So, be careful not to get Andy. Oh, there's Andy. We can get some food from Andy. He's gonna kill Andy. Thank you. Be super dire food. You can actually tame a dog with this. Funny. Look at these beautiful Andy flowers. Like, let me kill that sheep. It's not Andy. If it's not Andy, it's gonna die. You're not Andy, so die. Cool. Oh, Wolf is gonna help us kill not Andy. Yay, it killed not Andy. Oh, here's more not Andy. Kill it. Oh my god. Yeah. Yeah, boy. Oh, it's gonna kill more not Andy. Thank you. I didn't even tame this wolf, which is... Yeah. Good job. Good job, Yogi. Good job. Kill that. Kill that. Yeah. Thank you. Actually, the not Andy drops Andy, so that's pretty cool. So, yeah. Let's actually cook some Andy. Yeah, so we got some problem here, and that is that our wool is not the same color. So I'll do that. We need some wood. Andy wood. Andy's wood. Don't. No. Just not. Orange. Because orange is leaves. And yeah, we survived another day. Cool. We're just gonna cook this Andy up. Cook a lot of Andy. Let's just cook all this Andy. Yada yada. And there is more Andy, so we can craft more Andys. And put Andy in there. Like so. Let's just use this up, so whatever. So yeah. Need more Andy. So cool. You can't ever have enough Andy. Oh, Andy is dying. Andy's on fire. Hello, Andy. How is you doing, guy? Oh, it dropped an Andy. Nice. You can craft an Andy on an Andy right now. Cool. Let's craft a pickaxe. An Andy pickaxe. Honestly though, it gets a little bit tired to say Andy. Like Andy times, like, dang it. Right, just grab that stuff. Can we craft some more stuff? Yeah, let's just craft that thing. We crafted Andy. Let's organize our stuff a little bit. So yeah, whatever. So I think I'm gonna go back to assembly after this. Do some more assembly stuff. I think I know what to talk about right now. I just needed to take a little break. So yeah. Let's explore a little bit and then go back to assembly. Let's find another cave or whatever. But more non-Andys. Alright, so beautiful cave, let's go down. Yeah, let's just oh. Whoa, easy. Die, Andy. Non-Andy. Right, cool. So we're out of torches, out of Andy torches, so we're kind of screwed, so yeah, I hope you enjoyed that. We'll proceed with that another time, maybe. But for now, we're going back to assembly. So, let's see if this thing is properly. Rescale this so it's actually on the screen correctly. Yada yada yada. Yeah, alright, cool. So yeah, so let's go back in here and see what I can explain. Okay, why is this on top? Like all the time? Whatever. So how many people are watching right now? 0. Can't be right. If nobody's watching, I can end the stream. I mean, dang it. There we go. Yeah, let's see.
Greeny has just scored a touchdown. You're seeing that.
Right, we have 3 people viewing. Well, at least this is going on YouTube anyway, so that's fine. Why get chat only? That's fine. Oh dang it! How does this even work? Oh well. Multiplayer. Well, so let's look at the assignments actually. It might be nice. So go to the manual and over here, let's go to assignment 1. Show prior knowledge, blah blah. Chapter 2 assignments. Yeah, 0, 1. So exercise 1, it should be easy now. Now you know everything, so you should be able to do that in your own time. And here is more exercises of assignment 1 with an in-out subroutine. And we know that because you should have watched yesterday's stream, so everything should be clear for this. Assignment 2, parameter paths and local variables. We kind of went over that, so you can make a power subroutine. You just have to figure it out on your own, but you should have the basic knowledge to do that. So that shouldn't be difficult. Assignment 3 is copying that program to factorial as, and this is just basic recursion. So you just call the same function and you have to jump if it's like 1 or whatever, then you jump over it so it finishes the routine, and it should return n in the rex register after something in such a way that calls factorial with the number it reads instead of implementing by 1. Yeah, basically just put this number on a stack every time. So basic recursion you should use here. Cool. Pseudocode specifications. You should be able to write those. Not difficult. For A. Oh, this is 500 points. Cool. That's pretty cool. Test file 1 to be precise. Test file 2 to be precise. So it actually reads every line, compares it to the other file's line, and if they're equal, it's gonna go to the next line. If it finds a difference in that line, it will print that line, with the left file being the first, the right file being the second argument thingy. Yeah, that's pretty cool. So you gotta find out a way to read files in assembly. I have no clue how to do that, so I don't care. I'll figure it out someday. So yeah, I think I'm gonna end the stream here soon because I gotta do some homework too and finish my own assembly assignments, and we might look at this stuff later. Oh, look, it's not even required. You can even do hardcode the text you're comparing your source. If you do this, however, the student assistant will change this hardcode to text to confirm this program works with different texts as well. Yeah, that makes sense. The I and B options should be read from the command line. Again, it's not hard-coded. So these will be passed on the stack, I believe. By convention, your command line arguments follow first an integer that tells you how many arguments were provided. I always use 1. Name of your own program, and then the actual priority. That's by convention, so you should follow that. And yeah, can be found online. Cool. So yeah, I'm just gonna end the stream here. I hope you enjoyed, and I hope you have all your questions answered, and I'll see you next time.